Hi there. I just wanted to go through how to calculate the average atomic mass with you so that you could get some more practice in. So remember that the average atomic mass is the weighted average of the masses of the different isotopes that make up a given sample. So unlike a normal average where we just add everything together and divide by how many we have, the average atomic mass, you have to take into consideration what percentage we get from each of our isotopes. So, example number 1 here, I've got 2 isotopes of hydrogen that I'm talking about in this sample. 99.9885% of those hydrogens are hydrogen 1, which has a 1.0078 atomic mass units mass. The remaining 0.0115% is hydrogen 2, which has a mass of 2.0141. So to calculate the weighted average, the first thing that we're going to need to do, is we're going to have to convert each of these values to a decimal. Now remember, when you are given a percentage and you want to go to a decimal, you're just going to scoot that decimal place 2 to the left. And if there's not a number there, if there's like a gap, then you're going to put a 0 in that gap. And I'll show you what I mean here. So on the first one, 99.9885%. So that's going to be 0.999885. Okay. On the next one, it's 0.0115%. Our decimal goes here. See how there's a gap there? I'm just going to put a 0 in. Okay, so this new number with our moved decimal place is what we are going to use. So we're going to take each of our isotope masses, so for example, 1.0078, and multiply it by the abundance, which is that new decimal place. Because we moved our decimal, therefore we get rid of the percent. And we add all of those things together. That's what this means. Just means the sum, we add them together. So I am going to do 1.0078 atomic mass units times 0.999885. And I'm going to add that to 2.0141 atomic mass units times 0.000115. Okay, so I get 1.007684103 and 0.0002316 When I add those two things together, what I get is the average atomic mass of 1.007915725. Now, if I were rounding and using my significant figures, then I would probably go to like 3 sig figs, which would give me 1.01, but I wanted you to see the entire number. Okay, so this is if you plug in each of the pieces individually. You can also do all of this math all at once in your calculator all together. So let me show you how you do that. The next example is helium. So remember, the first thing we need to do is go from percent to decimal. So I'm going to move my decimal and put in a 0 if there's a gap. So now I have decimals instead of percentages. Instead of doing it separately, like I did up in the previous question, I can type it all in the calculator all at once if I use parentheses. Okay, so the way I would do that is parentheses 3.0 0.0160 times, so we got 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros, and then a 2. Plus, then a new set of parentheses for helium-4's isotope. Okay, in this question, just like the previous question, I only have 2 isotopes. So that's easy enough, and I get 4.002598027. This is the average atomic mass. But it doesn't matter how many isotopes I have. You just use a new set of parentheses for each of the isotopes. All right, so the final example that I have for you here is for zinc. There are 4 isotopes of zinc in the sample that we are talking about here. So each set gets a set of parentheses, and then we just add them all together. So remember, step number 1, we got to get to decimal, get rid of our percents. There we go. And zinc 64, zinc 66, zinc 67, and zinc 68 all get their own set of parentheses. There's 1. There's 2. There's 3. And then our last one. If you put it in parentheses like this and do a set of parentheses for each isotope, can't go wrong. So for this sample of zinc, we had an average atomic mass of 64.96198,643. Now, I want to bring your attention really quickly up here. Let's look at question number 2, or example 2. If this was a regular average, I've got a number here that's approximately 3, a number here that's approximately 4. So a regular average would be somewhere in the middle, about 3.5. But I've got almost 100% of my sample that has a mass of 4. So this weighted average gives us a mass of 4. This is how it's different. You cannot do a regular average calculation like you can if you're just calculating the average. You can't do that with isotopes and average atomic mass. So remember, we take each isotope and multiply it by its percent. So for this isotope, we have mass times the percent that has been converted to a decimal, and we do that for each one. Okay? And that is how you calculate average atomic mass.